1 more minute.
Sorry, George, are we allowed to input the answer because my Menti screen hasn't changed?
Oh, sorry. Thank you. You really are the hero of these. Can you do it now?
Yes.
Okay, great. Okay, 20 seconds. Vanessa, I actually don't know the answer to that question, but I'm sure Horatio does. So hopefully he will let you know if he's still here, or otherwise, if you ask in the Slack channel, I'm sure he will tell you how to watch the previous ones. Okay, so we've got 2 people said D, and you are correct. Well done. So 3 people said D. Good. So we won't spend too long going through it then, but basically you just need to add together the prices, Tabor and Ursa, and then divide the budget by that amount. And if I recall correctly, it comes out to 21 point something, 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 something. And so therefore that means you can buy 21 cars. Okay, so I think we had one more thing to do in percentages. So we'll do that, and then I'll tell you the plan for what we're going to do next, and then we'll start doing it. So given the final value and the percentage increase or decrease, calculate the initial value. So if a hotel had this many guests, 3,048 guests this year, and this was a 60% increase on last year, how many guests did it have last year? So we can think of it like this. This was the original amount. This is what we're trying to find out. We could call this X, or the unknown. That's the original number of guests last year. And then we know it increased by 60% of itself. And so the final amount, which we've been told, we could call the original amount X. The final amount, which we've been told, is 160% of X. Because it's a 60% increase. It was originally 100% of itself, so 100 plus 60, 160%. Okay, so we know that X times 160%, in other words, X times 1.6, if you convert that to a decimal, is 3,048. So X is 3,048 divided by 160%, or in other words, divided by 1.6. And when you type that into the calculator, you get 1,905. Okay, so the other 2 questions we just do in the same way. So total rainfall was 495% higher than April 2021. Sorry, this is in May 2021. If the total rainfall in May 2021 was 119,595 millimeters, what was the total rainfall in April 2021? So this is slightly unusual because we have this very big percent, but you shouldn't let that throw you off because it's still the same thing. So originally, the rainfall in April was obviously 100% of itself. Every number is 100% of itself. And then the rainfall in May was 495% higher than that. So 100% plus 495% gives you 595%. Okay, so therefore the rainfall in May was 595% times the rainfall in April. We're trying to find out the rainfall in April. So this number here is 5.95 times X. So to find X, we have to divide 119.595 by 5.95. So we added on the 1 basically, which is the original amount. And then we get 20.1 millimeters. And then finally, the number of books borrowed from a library decreased by 14% between June and July. If the number of books borrowed in July was 301, how many were borrowed in June? Okay, so if it decreased by 14%, that means that it went down to 86% of the original, because 100% minus 14% is 86%. So therefore, 301 is 86% of the original amount, which we could call x. In other words, original amount, so June amount, times 0.86 is 301. So we need to do 301 divided by 0.86, and then we get 350. And if that was too fast for any of you, or well, hopefully you know by now that all the syllabus notes and everything are accessible on this website, and it goes through everything much more slowly. Okay, so I put up the notes for ratio and proportion. Ratio and proportion is something I think people often find difficult. It can be a bit conceptually challenging to think about. And there's also there's quite a few skills in this one. I think there's actually 15 skill kind of boxes in these notes. It's like 17 pages long. So I think it'll probably take us this session and next session to go through all of this. Some bits are fairly easy, some bits are more difficult. And then maybe at that point, it'll be a good place to actually pause building up our toolkit and just try actually applying the toolkit that we've built up so far to some numerical reasoning test style questions, and then we can go back and add in the last few bits like averages and working with graphs and things. So that's kind of my current thinking. So anyway, let's crack on with this. So hopefully you all know where to find the notes. If you don't, we can hook you up with them. So given the ratio of two values, express it in its simplest form. Okay, so we've got this example here. Express the ratio 45 to 70 in its simplest form. So I'm actually going to use this whiteboard here. So the first couple of just basic things about ratios, just in case it's been a while since you used ratios. When we say ratios out loud, this colon here, we say 2. So we say 45 to 70. And so what this ratio tells us is like the proportion between two things. So in other words, for every 45 of whatever this represents, there are 70 of whatever this represents. So the example I put in the notes was perhaps it's the ratio of somebody's spending to their income. So for every 45 pounds of spending, they have 70 pounds of income. So it's not the same thing as a fraction, because a fraction is something out of the total. But this isn't, because the total of these two is 115. Yes. So this one will be 45 out of 115. So it's not the same thing as a fraction. It's a ratio between two things. Or it could be more than two things. You could have a ratio between three things or even more. Okay, so next thing you need to know is that ratios have equivalent ratios, just like fractions have equivalent fractions. So if you start with, let's go with just a smaller numbers, just so that it's easier to do the maths. So let's take the ratio 3 to 5. So if you take a ratio and you multiply every number in the ratio by the same number, then what you get is an equivalent ratio. So let's just take this ratio and times everything by 4. Okay, so take the 3, times it by 4, take the 5, times it by 4. So that gives us 12 to 20. And so what that means is that the ratio 12 to 20 and the ratio 3 to 5 are the same ratio. It's not actually a different ratio, it's just a different way of writing it. They are equivalent ratios, in other words. So the example I've put in the notes is it could be the ratio in a zoo of lizards to big cats. So this ratio here tells us, the top one, for every 3 lizards, there are 5 big cats. For every 3 lizards, there are 5 big cats. The bottom one tells us for every 12 lizards, there are 20 big cats. Those are just 2 different ways of saying the same thing. So these are equivalent ratios. And the same thing, if you divide all the numbers by the same thing. So let's say we divide both parts by 2. And then we would get 6 to 10. And 6 to 10 is equivalent to both of the other ratios. So these are all just different ways of writing the same ratio. Okay, so we have to apply this concept when we are looking for the simplest version of a ratio. So if we go back to our ratio 45 to 70, what we want to find is when we say the simplest version, what that actually means in maths is the smallest whole numbers that you can use. So ratios don't have to be whole numbers. You could have like 1.7 to 3.8, for example. That's a totally valid ratio. That's a fine thing to have as a ratio, just like you can with fractions. But it's not considered simple in the mathematical sense of the word. So we want to find the smallest whole number equivalent ratio to this. Now, the answer is 9 to 14. And the reason for that is because basically the biggest factor that you can divide both of them by is 5 and still get a whole number. Obviously, you can divide them by any number, but if you want the answer to be a whole number, an integer. And if we divide 45 by 5, we get 9. 70 divided by 5 is 14. In other words, 5 is the highest common factor of 45 and 70. Highest common factor. Now, you might now be thinking, but hold on, how do I know that 5 is the highest common factor of 45 and 70? Because I just said that. I didn't show you how I worked it out. So the good news is that you can get the calculator to do it for you. The bad news is you can only get a calculator to do it for you for ratios that have 2 parts, so something to something. If you have something to something to something, or even more somethings, the calculator will not be able to do it for you, but we'll come on to that next. But first, let's see how we can get the calculator to do this for us. So I said before that ratios are not the same thing as fractions, and that is true, and that is a very important point, because I don't want what I show you next to mislead you into thinking that ratios and fractions are the same thing. However, the steps, so when we're finding the simplest version of a ratio, what we have to do is find the highest common factor of both numbers and then divide them both by that number. Now, that's exactly the same process that we do when we find the simplest version of a fraction. So we could just put those 2 numbers into a fraction and get the calculator to simplify it for us. But it's really important that you realize this fraction here is not another way of writing this ratio here. Okay, 45 out of 70 has nothing to do with the ratio 45 to 70, because out of means out of the total. The total here is not 70, it's 115. So 45 out of 70 is not the same thing as 45 to 70. However, what we're basically doing is, because the calculator doesn't have a most calculators don't have a way of simplifying ratios, but they do have a way of simplifying fractions. And because the steps involved are the same, we're just going to use the fraction simplification. We're almost kind of like hijacking it, not for its intended purpose. We're just using it to get the calculator to do something, so it will tell us what the numbers are. So anyway, So let's put this in as a fraction, and the calculator will simplify it, and it tells us that the simplest version of this fraction is 9/14, and therefore we know that if we'd done the same process with this ratio, we would have got the ratio 9/14. And so that's how you get the calculator to do it. So we're just using the fraction function to kind of cheat, or to try of slyly get the calculator to simplify the ratio for us. Okay, hopefully that makes sense. So let's clear this. Now, what do we do when the ratio has 3 or more parts to it? So express the ratio 84 to 36 to 60 in its simplest form. Now, obviously, we can't use our fraction trick, because how are you going to put all 3 of these numbers into a fraction? A fraction only has 2 bits to it. And this is another illustration of the fact that ratios and fractions are not the same thing. So we're going to, unfortunately, this is the one thing that you can't really use the calculator for, but you can use the calculator to help you do the calculations involved in it, but you have to actually find, well, I'm going to show you 3 different ways to do it. So, well, actually, no, I'm going to show you 2 different ways to do it, and I'm going to tell you a third one that you might already know, but I'm not going to explain how to do it. So, the first way is to just find the highest common factor of these 3 numbers. So just to recap, we're looking for the highest common factor, the highest number that they can all be divided by, and get a whole number as the result of the division. And then we want to divide them all by that number. So one way to do it is just to list out all the factors of each of the numbers, and then just look through the 3 lists and find the highest number that is in all 3 lists. And you will find that it is 12 in this case. Now, that leaves the question of, how do you find out all the factors of a number? So the way that I like to do it, so if we want to find factors of 36, I like to draw it out like this and just do 2 columns. So we just start with the number 1, and then we go 36. Does it divide by 1? Yeah, of course, every number does. And it's 1 times 36 is 36. Does it divide by 2? Now, hopefully you know that it's an even number, and all even numbers divide by 2 to give a whole number. And in this case, it's 18. You could always use the calculator to do that division if you wanted to. Does it divide by 3? It does. And there is actually a trick. If you add up the digits of any number, if they add up to a multiple of 3, then it is, the number itself is a multiple of 3. So 3 plus 6 is 9, which is a multiple of 3. So therefore, this number is a multiple of 3. So 36 divided by 3 is 12. Does it divide by 4? So the trick for checking if something divides by 4 is actually just to check the last 2 digits. If that number divides by 4, then the whole number divides by 4. In this case, it's only a 2-digit number in the first place, so you just have to know your 4 times table, or you could just test it on the calculator and see, and it does divide by 4. It is 4 times 9. Does it divide by 5? No, because it doesn't end in a 5 or a 0. Does it divide by 6? Yes, anything that divides by 2 and 3 is divisible by 6, because 6 is 2 times 3. And hopefully you would know that 6 times 6 is 36. If you don't know your times tables that well, it's not the end of the world, because we've seen that most of this stuff can be done in the calculator. But it will probably make you more confident going into the test if you just take a bit of time between now and then, every day, few minutes, just practice your times tables. It will just make you a bit confident a bit quicker. Now, once we get to a number that we've already got in our list, or a number that's smaller or bigger than what we've already got in our list, then we know we've finished. So here we've got 6 and 6, so we don't need to keep going. So that gives you all of the factors, and you can do that for all of them. Find the highest common factor, and then divide all the numbers by that, And what you will get, I've got it written down here, is 7 to 3 to 5. So 84 divided by 12 is 7. 36 divided by 12 is 3. 60 divided by 12 is 5. Now, obviously, that's quite a long process. Another way that you could do it is you, instead of looking for the highest common factor, just look for any common factor and just keep repeating the process until you can't do it anymore. And obviously, the bigger the factor, the better. So 84 to 36 to 60. So we just say, okay, let's just look for any factor that they all have in common. An obvious one is 2, because they're all even numbers. Okay, so let's just divide them all by 2. That's the starting point. So we get 42 to 18 to 30. And you go, okay, let's look for another factor they all have in common. Now, you could go, okay, let's divide them all by 2 again because they're all even. But if you know your times tables, you might spot that they're all in the 6 times table. And therefore, we could just divide them all by 6. So 42 is 7 times 6, 18 is 3 times 6, and 30 is 5 times 6. So we get 7 to 3 to 5. Now, at this point, we've finished. How do we know we've finished? Well, in this case, they're all prime numbers. So we know they won't have any factors in common apart from 1. If they weren't all prime numbers, you'd probably have to just check the factors and make sure they don't have any factors in common. Then you know you're finished. Now, if we hadn't spotted the 6, the divide by 6, so this one was divide everything by 2, this one's divide by 6. And just to be clear, we're not dividing the ratio by 6 because that would change the ratio. We're dividing every number in the ratio by 6, which actually gives us an equivalent ratio. So we're not actually doing anything to the ratio, we're just writing it in a different way. Now, if we'd gone down the route of dividing by 2, just to show you, we would have got 21 to 9 to 15, which are all multiples of 3. So then we divide by 3, and we get 7 to 3 to 5. So basically, just keep doing it, and eventually you'll get there. But the bigger the numbers, the factors that you find, the quicker you'll get there. Okay, so the third and final method, I'm not actually going to show you in full how to do it because it's a bit involved. Well, maybe I'll just quickly run through it. But so the reason I'm going to mention it is because some of you might already know how to do the first bit of this. So you can find the highest common factor by finding the prime factorization of each number. So if we take 84, 84 is divisible by 2, 2 and 42. Now 42 is 7 times 6. 2 is a prime number, so we circle it. 7 is a prime number, so we circle it. 6 is 2 times 3. 2 and 3 are prime numbers. Therefore, 84 is equal to 2 squared times 3 times 7. If you're not familiar with finding prime factorizations, it might be worth looking up, but I'm not going to go over it in detail because it's not essential, because there are other methods, as I've explained. And if you do this for all 3 numbers, you can figure out that the highest common factor is 2 squared times 3, because they all have 2 squared times 3. 2 squared times 3 is 4 times 3, which is 12. The highest common factor is 12. So then you just divide them all by 12. Okay, so let's move on. Given information about the quantities of different items, express this as a ratio in its simplest form. So a lot of these are going to end in its simplest form. That's why I started with finding the simplest form. We'll just do that skill. That skill is going to be used in all the other skills, or most of the other skills afterwards. So in his allotment, Jim grew 66 carrots and 143 tomatoes. What is the ratio of carrots to tomatoes grown by Jim? Give your answer in its simplest form. Okay, so what I like to do, and it might seem unnecessary in a simple question like this, but it's a good practice to get into for when you start doing more difficult questions, is write down the ratio, write down the kind of word version of the ratio we're looking for. So in this case, we're looking for the ratio of carrots to tomatoes. You could even write out the full word, carrot, tomato, with the colon in between, 2 dots. So that's what the question asks for, ratio of carrots to tomatoes. So really make sure that you identify this carefully, because they might trick you by giving you the carrot information first and then the tomato information, but then they'll ask you for the ratio of tomatoes to carrots. They'll switch it up, right? So don't just assume it's going to be based on the order in which they gave you the information. So you've got to really focus in on this and go, okay, what am I being asked for? I'm being asked for the ratio of carrots to tomatoes. Write that down straight away before you do anything else. I know that sounds unnecessary because this is a really simple question, but it's a really good habit to get into. So we got the numbers here: 66 carrots, 143 tomatoes. So we can write that underneath. I like to kind of line them up like this. It makes it really clear. So we already know how to simplify. We can just use, because there's only 2 parts to it, we can just use the calculator and we get 6 to 13, and that's the answer. The next one, on Monday, a website had 126 mobile users, 75 desktop users, and 33 tablet users. What was Monday's ratio of mobile users to desktop users to tablet users? Give your answer in its simplest form. So we're looking for mobile to desktop to tablet. We're just going to make sure we read that really carefully. Mobile to desktop to tablet. And then we're going to just copy the numbers over: 126, 75, and 33. Now, because there's 3 parts to it, you have to go through the longer process of simplifying it. I'm not going to take you through that now, but if you did, you would realize that the highest common factor of all of them is 3. And so when you simplify it, divide them all by 3, you get 42 to 25 to 33. And just this is an example where they're not all prime numbers, but you can actually tell that they have no more common factors, because 33 is 3 times 11. Sorry?
Isn't the last one 3? I mean 11, not 30.
Oh, yes. Yes, you should teach this course. I should be in the audience. Thank you. So the last one is 11, which is a prime number. This one is 5 squared, and this one is 7 times 3 times 2, 7 times 6. So they don't have any common factors, so you know you've finished. Thank you. Given how many times larger or smaller one value is than another, work out the ratio of the 2 values in its simplest form. So it's pretty straightforward. So a company's sales are 3 times its expenditure. What is the ratio of sales to expenditure? Give your answer in its simplest form. Now you may be thinking, obviously it's 3 to 1, and you are correct, it is 3 to 1. But the wording on these type of questions can catch you out. So I'm using simple examples to start with, but I'm trying to give you good habits that you can follow, that will, if you start training this way on the simple examples, then when you get to the hard ones, you won't trip yourself up. So we want the ratio of sales to expenditure. Oh no. Sales to expenditure. And we're told, so first thing you've got to ask yourself is which one's bigger. That's how I like to think of it. So the sales are 3 times the expenditure. That means that the number for expenditure, we're going to put 1. Now, what number do we want for the sales? It's going to be 3, because it's going to be 3 times as much. So it's just 3 to 1. Okay, easy. Now, the number of geese living on a lake is 5 times less than the number of ducks. What is the ratio of geese to ducks living on the lake? It's a little bit more complicated now, because the number of geese is 5 times less than the number of ducks. So we're looking for geese to ducks, but we know that ducks is the bigger one. Okay, so ducks is the bigger one. Geese is the smaller one. So the smaller one is going to be the one that is represented by the number 1. So it's going to be 1 to something. Well, it's 5 times less. So it's going to be 1 to 5, because we want the number of ducks to be 5 times more than the number of geese. Another way you could think of it is that the number of geese is 1/5 the number of ducks. And if you simplify that, you actually have to times them both by 5, which gets you to there. Okay. So in a situation with 3 or more values, given information about how many times larger or smaller different values are than each other, work out the ratio of all the values in its simplest form. So it's easier to just look at a question, at an example. So Tina's pocket money is 3 times as much as Rachel's pocket money. Rachel's pocket money is twice as much as John's. What is the ratio of Tina's pocket money to Rachel's pocket money to John's pocket money? Give your answer in its simplest form. So again, it's immediately focused on what are we being asked for. We're being asked for the ratio of Tina's pocket money to Rachel's to John's. So let's just write that down. Because once you write that down, you don't have to hold it in your head. And that frees up space in your head to focus on the next thing. So just get that down on paper. That's what we're looking for. Okay, now let's go through the information. Tina's pocket money is 3 times as much as Rachel's pocket money. That means that Tina to Rachel is 3 to 1. Excuse me. Rachel's pocket money is twice as much as John's. So Rachel to John is 2 to 1. So we want to combine these ratios into one overall ratio with 3 different bits to it. So how are we going to do that? Well, you can combine ratios as long as they have an item in common. So in this case, they both have Rachel in them. They both have R. That means we can combine them. But before you can combine them, you need to make the number that represents that item the same in both ratios. You could do that using equivalent ratios, right? So we need to find equivalent ratios such that this number is the same in both of them. Once this number is the same, the number of the item that is in both ratios, the R in this case, Rachel, once that number is the same, then you can just merge them into one ratio. So what we want to do is because we've got 1 here, we've got 2 here, the easiest thing is just to times this by 2, so then that will be 2 and they'll both be 2. But obviously if we times this by 2, we also have to times this by 2. So we change this to 6 to 2, which I will emphasize again is not a different ratio, it's just a different way of writing the same ratio, it's an equivalent ratio. So now we've got Tina to Rachel is 6 to 2, Rachel to John is 6 to 1. So we can just put all that together. Tina to Rachel to John is 6 to 2 to 1. So Rachel to John is 2 to 1. We've held on to that. We haven't changed that. Tina to Rachel is 66 to 2. We've got that as well. So everything is consistent, and that's the answer. Now, it just occurs to me that you could have, let's say, for example, the ratios you were trying to combine were like 1 to, let's say, 8 and 6 to 5. You'd have to change both of them, right? So if this was the shared item, the 8 and the 6, so you want to look for a common multiple. So you could just multiply them together. 8 times 6 is 48, so you could go 48. But the lowest common multiple is actually 24. So if you times this by 3, or times both parts of it by 3, times both parts of this by 4, I'm doing this on the fly here, so tell me if I make a mistake, then you'd be able to combine them, 3 to 24 to 20. Maybe I haven't made the question pack yet, so maybe I'll put some questions like that in the question pack. Okay, so there are 4 buildings, A, B, C, and D. A is 3 times taller than B, C is 4 times shorter than B, D is twice as tall as A. What is the ratio of the heights of the 4 buildings? Give your answer in its simplest form. Okay, so what we're being asked for, the ratio of the heights, the 4 buildings are A, B, C, and D. So let's start by just writing that down. A to B to C to D. Okay, so we've got that written down. We don't have to think about that. So we're told that A is 3 times taller than B. So A to B is 3 to 1. D is twice as, C is 4 times shorter than B. C is 4 times shorter than B. So B's number should be 4 times C's number. So the easiest way to do that is it's going to be 4 to 1. And we're told that D is twice as tall as A. So A to D is going to be 1 to 2. So we want D's number to be twice as much as A's number. So we're not going to combine them. We just combine 2 of the ratios into 1, and then we combine that ratio with the last one, and then that will give us all of the ratios in one ratio, A to B to C to D. It doesn't matter which order you do it in. You could merge these ones and then merge that with this one. It doesn't matter as long as you can find a way. That's fine. So but let's just start by merging these two here. So they both have B, but we need to make the same number of parts. Let's call these parts, like the number in the ratio. So in the first ratio, B is represented by 1 part. In the second ratio, it's represented by 4. So the simplest thing to do is to make this 4, and that means timesing it by 4. So we also have to times this by 4. So we get 12 to 4. So now we can merge them, and we get A to B to C is 12 to 4 to 1. Okay, now we've still got this A to D. So we're trying to combine these two now. A to D is 1 to 2. Here, so we've got A in both of them. That's the common element or the common item. But here we've got a 12. Here we've got a 1. So we just want to times this by 12. That gives us 12 to 24. So now we can merge them together. So we get A to B to C to D is 12 to 4 to 1 to 24. Okay, hopefully that made sense. I will clear that off. Okay, this one's super easy. Given the ratio of A to B, state the ratio of B to A. So the ratio of guitars to keyboards sold by a music shop is 23 to 9. What is the ratio of keyboards to guitars sold by the shop? The answer is 9 to 23. Simple as that. Okay, so if the ratio of two things, so guitars to keyboards is 9 to 20, 23 to 9, then the ratio of keyboards to guitars is 9 to 23. You're just swapping the way around that you're writing them. It's the same information. Different ratio, but different order of things. So it's the same information. Okay, so moving swiftly on. Given the ratio between two or more values and given one of the values, calculate the other values. So the ratio of apples to satsumas to pears in a fruit bowl is 3 to 5 to 2. If there are 15 satsumas, how many pears are there? So let's just start by writing down using letters the ratio that we're looking at. So apples to satsumas to pears. That should always be, well, my recommendation is that would always be your starting point. Okay, now we know the ratio is 3 to 5 to 2. So we could think of this as parts, like 3 parts apples to 5 parts satsumas to 2 parts pears. Or for every 3 apples, there are 5 satsumas and 2 pears. So if there are 15 satsumas, how many pears are there? So the actual number of satsumas is 15. I'm going to put that in a circle just to indicate that it's the actual number rather than the parts in the ratio. So we know that 5 ratio parts represents 15 actual items. This is not standard maths terminology, notation that I'm using here, by the way. I'm just making up my own notation. You could write it out in words. 5 parts equals 15 items. Because I'm using a mouse, it's going to take too long to do that. So then you have to work out, well, how much does 1 part represent? Because once you know how much 1 part represents, you can work out the numbers of items of everything. So 5 parts is 15, so 1 part is going to be 5 times less than that, so 15 divided by 5, and that gives us 3. Okay, so number 1 in the ratio would represent 3 items. Therefore, what does the question ask? How many pairs? So we've got the number 2, so that's going to be 6, 2 times 6. And if we had to find the number of apples, that would be 9. So there's 3 in the ratio. Each number in the ratio represents 3 items. 3 times 3 is 9. Okay. Given the ratio between 2 or more values and given one of the values, calculate the total of all the values. So this is similar but different. So Alan's pencil case contains black pens, blue pens, red pens, and green pens in a ratio of 4 to 5 to 2 to 1, and there are no other colors of pens. If Alan's pencil case contains 10 blue pens, how many pens does it contain in total? So, So we've got black to blue. I'm just going to do lowercase b for blue to save time. Red and green. And the ratio 4 to 5 to 2 to 1. So we're told the actual number of blue pens is 10. So this 5 in the ratio represents a real amount of 10. Again, this is not standard maths notation. I'm just saving myself time because it would take ages to write out in words. 5 parts equals 10 pens. But if you look in the notes, you'll see how I've written it there. It's up to you how you want to do it. So we want to know how much does 1 part equal. So just like last time, you have to divide it by 5. Obviously, it wouldn't always be 5. It's just a coincidence. So 1 part in the ratio represents 2 pens. So how many pens are there in total? So we could work out how many pens of each color and then add them all up, but we don't need to do that. All we need to do is work out how many parts of the ratio there are in total. So 4 plus 5 plus 2 plus 1 is 12. So in total there's 12 parts. So how many pens in total? Well, each part represents 2 pens. So if there were 12 parts in the ratio, then the number of pens is 12 times 2, which is 24. Okay. And then, moving on. Given the ratio between 2 or more values and given the total, calculate any given value. So this is like the reverse of what we just did. This is doing the other way around. So a bike shop sells 3 types of bikes: mountain bikes, road bikes, hybrid bikes. Last year, the ratio of mountain bikes to road bikes to hybrid bikes, 4 to 7 to 3. If the shop sold 112 bikes last year, how many of them were mountain bikes? So mountain to road to hybrid, that's the first thing we're going to write down. Let's get that on paper. And the ratio was 4 to 7 to 3. Now the actual number of bikes, the actual total number of bikes was 112. So, okay, so what's the total number of parts of the ratio? Because that's the number that represents the total number of bikes. So 4 plus 7 plus 3 is 14. Okay, so that means that 14 parts of the ratio represents 112 bikes. 14 parts represents 112 bikes. So what does one part represent? We have to do 112 divided by 14, which is 8. So one part in the ratio represents 8 bikes. So we want to know how many mountain bikes were sold. In the ratio, we've got the number 4, okay? So if one part in the ratio represents 8 bikes, we've got 4 parts, so we have to do 4 times 8, and that will give you 32. So 32 is the answer, 32 mountain bikes. Another way you could do it, which is kind of the same thing but different way of thinking of it, is there's 14 parts in total. 4 14ths times 112 will give you the answer, because it's 4 14ths of the total. And if you think about it, that's what we did, because we did 112 divided by 14 and then we multiplied by 4. So simple way of thinking of it. Okay, so given the ratio between 2 or more items, calculate the fraction that a given item is of the total. So in a school, the ratio of the number of students studying French to the ratio of students to the number of, the ratio of the number of students studying French to the number of students not studying French is 7 to 4. What fraction of the students are studying French? Okay, so if we think about it, so we've got studying French, which we'll just call F, to not studying French, which we'll call N, so not French, and that ratio is 7 to 4. So if you think about it, if this is like all the students, for every 7 students studying French, there are 4 students not studying French. So drawing things out spatially, like visually like this, can sometimes be helpful. So what we're looking for is what fraction of the students are studying. I think one of you's got your mic on, by the way, unintentionally. What fraction of the students are studying French? So what you don't want to do is like 7 over 4, because as I said earlier, ratio is not a fraction. We want to know what fraction of the total number of students are studying French. So the total number of parts of the ratio is 11, right? So this is like 11. Doesn't mean 11 students. We don't know how many actual students, but just the number of parts of the ratio adds up to 11. Now 7 of those 11, 7 parts out of 11 parts are studying French. So therefore the answer is 7 over 11. 7/11ths of the students are studying French. Now, you would obviously have to simplify whatever fraction you got. In this case, it's already in its simplest form, which you might spot from the fact that they're both prime numbers, but you can always check on the calculator. So, yeah, obviously you don't have to draw all of this out. You could just do 7 divided by 11 on your calculator and you'll get 7/11ths and you'll be done with it. But I'm just going through in a more methodical way, because you might get answers with much bigger numbers or that are hard to do in your head. Sorry, questions, not answers. Okay, cool. So now this one sounds similar, but it's actually different. So in a situation where there are two values, oh no, sorry, this is not, this is the other way around one. So in a situation where there are two values, given the fractional percentage that one value is of the total, find the ratio between the two values expressed in its simplest form. So we've got about 2 minutes, so I'll see if I can just go through one of these. So a vet surgery only treats cats and dogs. Last year, 2/5 of the animals treated by the vet surgery were cats. What was the ratio of cats to dogs treated by the vet surgery last year? So 2/5 of them. So first of all, the ratio of cats to dogs, that's what we're looking for. So let's write that down. Now, 2/5 of the animals were cats. And it only treats cats and dogs. So therefore, it follows that 3/5 of the animals were dogs. Okay, because the total number is like one of itself, not literally one animal, but one representing the whole. And so 1 minus 2/5 gives you 3/5. And so you could simplify this on the calculator, because you can actually enter a fraction as part of the fraction, like so. The numerator and the denominator of the fraction can be fractions, and it would just come down to 2/3. So therefore we know the ratio is 2:3, just using our little fraction trick there. Or you might just do it by inspection. Is okay, 2/5 to 3/5. Well, we just multiply them both by 5 and we get 2:3. So you might not need to use the calculator there. And then the second question, which is using percentages, says a bag of marbles contains large marbles and small marbles. If 20% of the marbles are large, what is the ratio of large marbles to small marbles? So we're looking for the ratio of large marbles to small. 20% of them are large, so it follows that 80% are small, because there are only large and small marbles. There are no other kinds of marbles in the bag. And so obviously the total number of marbles is 100%. 100% minus 20% gives you 80%. So this is the ratio 20 to 80, because 20% to 80% is the same thing as 20 to 80. Because remember, percent really means like divided by 100. And so you can just times them both by 100, and it's 20 to 80. Now, obviously, you want to simplify that, and you get 1 to 4. So it's a 1 to 4 ratio, which, you know, you might be able to get there quicker by just kind of thinking about it. But it's good to have a formal method, because you might get answers with nasty numbers, and it's nice to just be able to go through it methodically. Okay, so we actually got through a decent amount of that. There's still a few more things. Only, what, 3 or 4? Okay, so next time we will finish off ratio and proportion, and then we'll pause, because we've now got quite a big toolkit of skills. So we'll actually try applying that to more difficult numerical reasoning test style questions. And then, oh, the only other thing I want to say is, like, please do practice using the question packs, because you can sit there and understand everything I'm saying and think, okay, I've got this now. But unless you actually practice, you've got to, you know, there's always going to be little mistakes. You might forget a little aspect of it. You've really just got to sit down and work through questions, and then be like, okay, I've really mastered all these skills. I've got them at my fingertips, so that then next week when we start going through these questions, you're just going to be able these things are all going to be readily accessible and available to you. Okay, so we'll finish there. Thank you, as usual, for coming.